And welcome everybody to our daily space weather video bonus segment. First thing we're looking at is the total electron content, and we're seeing some major GPS errors around the world, some high levels of electron flux, some relativistic particles causing internal charging on satellites. We'll get to it momentarily. This is the most likely places for GPS errors where you see those red blobs, and we're seeing significant ones. I'm going to let it play through one more time here, as we're seeing very high levels of electron flux and a bit of chaos there in the electron bands as well. It's mostly organized around the equator at noon, but we're seeing huge bands here of essentially surplus electrons, and some satellites are not fans of that. You can go view this yourself if you like at the Space Weather Prediction Center. And let's move on to cover lots more things. So here's a diagram of what we were just looking at. You're looking at the area in between approximately here at about 12,500 miles and your handset. The free electrons in that region are what you're looking at. So we've got major charging hazards here all across the just south of the equator there, some major internal charging for satellites. Don't be surprised to see communications breakdowns and little anomalies in things like your weather satellite feeds and things like that. You can see very high levels of electron flux here. That's the 1-year chart to put it in context. The highest levels we've seen in months. And we brought up the 7-day chart here to show you how high those levels indeed are. Normally we only show the 3-day chart on the channel. I just wanted to show the 7-day chart to put it in context there. We're continuing to see electron warning levels here, both on the GOES 16 and 17 measurements. I did call this. I expected this to be a little bit higher. Sorry, NOAA. I had to adjust your forecast. We can expect to see a dip in this when the coronal mass ejection arrives, perhaps. No arguments with the forecast at the moment. Next, we're going to show you the ionosphere. The F layer is located at about 300 kilometers of altitude. And the reason the F layer is so important is because the F layer is where the GOES 16 and 17 are endeavoring to make their measurements. So when they're measuring the proton flux and the electron flux and so on, they're doing it from their geosynchronous orbit using radiography for the F layer. So here is the ionogram. It's courtesy Australian Government Bureau Meteorology. And things aren't really looking that anomalous at the moment. We will show you the anomalygram as well to put it into context. So here's the anomalygram, anomaly in megahertz from the 30-day median. For all you statisticians out there, thanks for correcting me when I say things wrong. I endeavor to be a well-rounded scientist. Anyway, mostly high-frequency anomalies at the moment. We'll bring up the latest image. There's 1230 Universal Time ionogram. There's 1230 Universal Time anomalygram. Some low-frequency anomalies there over Southeast Asia, the Central Atlantic, and Central Africa. Continuing on to welcome you to the Neo-Renaissance. Did you know that we're in the process of writing a paper to explain the underlying mechanisms that cause the solar sunspot and solar polar field reversal cycles? It's true, folks. If you weren't aware, hey, welcome to Neo-Renaissance. Congratulations on realizing the channel exists. Please support the channel via the links below the video. We need your assistance to get the content onto screens, apparently. I'm not so sure algorithms are helping. Consider becoming a member of the Smash Team if you'd like to support the channel in a Patreon-esque sort of way. We replaced Patreon with a better site, our own, smashamash.com/SmashTeam. There's a teaser. Gold and silver Smash Team members receive more, so consider signing up for that. Thanks to all who have. Based on a viewer request, we also updated our Redbubble page. We're going to show you a quick teaser of what's going on there. You can find links below the video to that as well. Thanks to everybody who's picked up merch. Also, make sure you follow us on Twitter. There's all kinds of stuff coming out on Twitter. Highly recommend you get on Twitter. If you're not, set up a new account. Do what you got to do. Get on Twitter. It's highly recommended. It's great for networking. Twitter.com/smashamash. Next thing we're going to look at are the hydrogen alpha imagery from some ground-based solar observatories. And the latest one we've got here is Cerro Tololo, Chile. Once again, don't be surprised to see this Sunspot 2941 produce a major flare, coronal mass ejection, even relativistic particles. It's moving closer and closer to Earth as the sun is big. Continuing on to show the latest intensitygram and magnetogram. There's a colorized magnetogram. Back to the intensitygram. These sunspots have largely remained stable. They've degraded a little bit here over the past 24. I think that's still beta class. That's still beta class. Certainly, that's beta gamma class. Still likely to produce major flares. 2943 down here has, I think it's shrunk a little bit since yesterday. Let's take a look at the fields. There are the fields of 2943. Here's 2939, the main flare producer. And most importantly, 2941. It's quite monstrous. It's one of the largest sunspot groups of solar cycle 25 to date. Here's some additional imagery, and we're going to go with helium, ionized helium, 304 angstroms, part of the ultraviolet light spectrum for the remainder of the video. So here's the NASA GOES 16 SUVI with its great wide field of view. Fantastic at showing solar prominences, the early portion of coronal mass ejections, and filaments. They're all essentially the same phenomenon, folks. So for all of you who like to see close-ups of solar flares, here's one in ionized helium. You should see a C4.9 flare there. That happened at about 2140 Universal Time. And we'll zoom out to close out the video. Once that plays through, there's just the western limb view. Spectacular high-resolution imagery there from the Solar Dynamics Observatory. You can see that coronal hole rotating in there on your left of your screen. Little bright spot in the middle of that coronal hole is always interesting. And make sure you watch our previous video about fields and features. And we'll end the video for our bonus feature segment here today with the fully zoomed out view from the SDO, 304 angstroms, ionized helium. Congratulations on realizing the channel exists, and may that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of Smash News Network, least busted name in news.